This mini lesson is for MEA 201, or is to estimate or calculate the length of a line segment based on other lengths given in a geometric figure. So I'm going to start with some basic examples where we see just lines. And then we're going to also see in our skill sheets different geometry figures, like pentagons or triangles or squares or rectangles. So let's first just discuss what it means to find the length of a segment. So the length of AB, when they see two letters next to each other, that just means the distance between this point A all the way to this point B. So this is what we're trying to find. We want to know what this segment length is if we know that the total length AC, so from point A all the way to point C, is 17. Well, if I want to figure out what to call AB, or what length AB is, I solve this equation. X represents the length of AB, and BC represents, or 4 represents the length of BC. So that's supposed to equal 17. So if I were to add the length of AB plus the length of BC, I get the full length of AC. So that's why my equation looks the way it does here. I take the little part X plus this part 4 and I put them together to equal 17. So I just subtract that 4 and I get X equals 13. Now I'm sure that you guys could also do that in your head, knowing that the whole length was 17, you take away that little portion. But this is going to help us when we start getting into more complex equations, when you have multiple, something like maybe 3x minus 2, and not just x. So just get used to setting up the equation so that you can do that in multiple settings and not just, in your head. Now in problem 2, this is a new topic for you guys, or a new vocabulary term. It says B is the midpoint of AC. Now the midpoint of AC just means the halfway point, so it splits the distance between A and C in half. So we mark that in geometry with a little hash mark like this. So AB is equal to BC. That's what that means if you have a midpoint. B is right smack dab in the middle of A and C. So then it asks us to find the length of AC. It wants us to find this whole length if we know that AB, this part, A to B here, is 9. Well, since A to B is 9, B to C must also be 9. So we're going to add those two up together. AB plus BC should equal 9 plus 9, and that's going to give me 18. The length of AC is equal to 18. Now we're going to start talking about polygons. Now a polygon is just a shape with straight sides. So I'm sure you're familiar with a square. This is a shape that you've probably seen for a long time, but I just want to reiterate some of the things that you know about a square. One, all sides of a square are equal. So you're going to see in your diagrams now these little tick marks that show that each one of these sides is the same. And notice I'm using the same number. So I could use 2 here, but then I would have to use 2 tick marks here and here in order to show that they're all the same. As long as one of those sides is different, that's showing that they're not all 4 the same. So we want to make sure that we have the same number of tick marks. We also know that all angles are equal, and each measure of those angles here is 90 degrees in a square. Now a parallelogram is another polygon, and a parallelogram is special because opposite sides are parallel. So opposite sides parallel is shown here. We actually use these little arrows. Since there are 2 arrows on this one, that means that it would be parallel to whatever has 2 arrows as well. So in this case, we might see this written out as AB is parallel. So we use these 2 lines here to represent parallel to DC. Also, AD is parallel to BC. Opposite sides are also equal within a parallelogram. So we could also mark this side, AB, the same as DC, and we can also mark AD the same as BC. Okay, I want to show that they are different because if DC and AD were all the same, then it would be a different shape. That shape would actually be a rhombus. So a rhombus is more special than a parallelogram. Not only are its opposite sides parallel, like we show here, so it's still a parallelogram, but there's something even more special about a rhombus. In a rhombus, all of the sides are equal, kind of similar to a square. So see now that I'm only using 1 tick mark to show that every single side here is the exact same size. So it's different than the parallelogram, where you have here side AD is the same size as BC, but this side DC is the same size as AB. They do not have to be the same size together. If they were, it would be called a rhombus. Okay, next up we have a trapezoid. A trapezoid only has one set of sides that are parallel. So one set of opposite sides are going to be parallel to each other, and that's what you get when you have a trapezoid. So if you have two sets of opposite sides parallel, then we call that a parallelogram. If only one set is parallel, we call that a trapezoid. Next up, we have an isosceles trapezoid. In an isosceles trapezoid, the sides that are not parallel are the same size. So that word isosceles, we've seen that before in isosceles triangles, where you have two sides of a triangle the same. So it's the same idea here. We see two sides of our trapezoid the same. It's not the sides that are parallel though. Those are going to be parallel. You have one set of sides parallel and one set of sides that are the same size. The last vocabulary term I'm going to talk about is a midsegment. Now the midsegment of a trapezoid, and we can tell that this is a trapezoid here because we have one set of sides parallel. This is not an isosceles trapezoid though, because these two sides are not the same size. But a midsegment is just a line that connects the midpoints of the legs of the trapezoid. So E is a midpoint, and that's why you're seeing these tick marks the same here, because this segment is the exact same size. EC is the exact same size as DE. And on the other side, F is the midpoint of AB, so the length of AB here, or sorry, AF is the same as the length of FB on the side. So a midsegment is just a special segment that joins these two midpoints, E and F. It goes through the middle of the trapezoid, and that's how you can also remember that it's called a midsegment. Now what's special about the midsegment is if I were to add the sides of the bases, so the lengths of the bases, let's say that this one is 5 and this one is 8, the midsegment is half of the sum. So to find EF, I would take the length of DA, 5, plus the length of CB, which is 8, and I would cut that in half. So I get EF equals 13 over 2, which is 6.5. So the length of EF would be 6.5. So it's this segment length here by finding the length of this plus the length of this and then dividing it in 2. I would like you to pause the video right now and then apply what we just learned in problems 3 and 4. So I'd like you to try these ones on your own and see if you understand the vocabulary and how to solve some of these problems. So go ahead and pause, and then when you replay, you're going to hear me explain the solution as well. Okay, so now that you're done pausing, let's go through the solution. In rhombus ABCD, so this is an important word here, it tells me that it's a rhombus, and then it tells me that AB is 12 and BC is x plus 7. So they already showed that to me in the diagram as well. Sometimes they won't, so you're going to have to put those values inside your diagram. We're supposed to find the value of x. Now remember that a rhombus has all sides equal, so I can show that with tick marks here to show that each one of these sides is the same. Now that I know that the sides are equal, I have an equation that I can set up. X plus 7 must equal 12. Solving for this, I get x equal to 5 after I subtract that 7, and this is the value of x. So give yourself a round of applause if you got that one right. Now in number 4, it says to name the midsegment of the trapezoid and then to find its length. Now when I want to look for a midsegment, I want to find the midpoints of the legs of the triangle. Now, of the trapezoid. In this shape, the trapezoid's bases are ZY and WX. And you can tell that these are the bases because these are the sides that are parallel, which means that the leg YX and the leg ZW here is where you're going to try to locate the midpoint. Now, I already have this segment in blue. I kind of wanted to reiterate, the color here so that you can see it, but that's how you would find the midsegment. So BG is the midsegment, and to find its length, remember all we have to do is add the two bases. So we're going to add 25 and 15, and then we cut that in half. So we have 25 plus 15, which is 40, divided by 2, and that gives me that BG is equal to 20. So BG is the midsegment, and BG's length is 20. Okay, for the last skill of MEA 201, our extension skill is going to be to compute the perimeter of our polygons. Remember, a polygon is just a figure with straight sides, and the perimeter just means you're going to go around and add up all of the parts. Now, in this case, it gives me a new vocabulary term here. It says the polygon is equilateral. To be equilateral, if you break this word down, equa, meaning equal, and the word lateral, if you ever watched football, a lateral pass is a side or backwards pass. Lateral, to move laterally, means to move side to side. So this is saying that this is equal sides. Okay, the word equilateral literally means equal sides. So if it has equal sides and this perimeter is what I want to calculate, then I'm going to put a 4 here, 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 and here because each side is 4 inches. Now I could also recognize that this is a hexagon. It has 6 sides. And all of these are the same, so I can mark this as the same. And then since I know it has 6 sides, I can also, instead of writing 4 6 different times, I can write 4 times 6. So I end up with a perimeter of 24 inches. Okay, that's the end of the lesson for MEA 201. Nice job. Get started working on those skill sheets.